Unit 11, Day 2. Today we're going to talk about pyramids and cones and finding the lateral area, total area, and volume. So for a pyramid, we still need to practice naming pyramids because the base can change shape. And similar to that of a prism, the name is dependent on what shape the base is. So my base is a square because it shows that all sides are congruent. So since the base is a square, this is a square pyramid. All right, to find the perimeter of a square, the formula is 4 times s, which would be 4 times 8 in our situation, which would end up being 32 feet. To find the area of the base, and since it's a square, it would be side squared. So that means it's 8 squared, which would be 64 feet squared. Now we have two dashed lines on our pyramid, which are very helpful lines. The red line represents our 3D height, which we don't know at this particular time. The blue dashed line represents slant height. So we can go ahead and write that down. The slant height is 14 feet. Together, the red line and the slant height line can form a right triangle. So let's isolate that right triangle from the pyramid. Slant height is 14. The bottom of our right triangle will be half the side of the square, so that would be 4. And then what is left would be our 3D height. So since it's a right triangle, we can use Pythagorean's theorem to find our 3D height. On this right triangle, we have A and C. So the shortcut to find the 3D height would be the square root of 14 squared minus 4 squared. And you can plug that in the calculator in one step if you have the Wabbit EMU or a TI graphing calculator of your own. Otherwise, you'll have to do it in stages on a scientific calculator. So when you plug it in, you should get 13.4. And since it's height, it's feet. Now we have all the necessary pieces to our puzzle. The formula for lateral area of a pyramid is 1/2 perimeter times slant height. So that's 1/2 32 times 14. And when you put that into your calculator, you would get 224 feet squared. The formula for total area for a pyramid is 1/2 perimeter times slant height plus the one base, because a pyramid has only one base. So essentially, it's your lateral area plus your base. Knowing that, we can bring down our 224 from above, and we just need to add our base area, which was 64, which we did earlier. And when you calculate that in your calculator, you should get 288 feet squared. The volume formula for a pyramid is 1/3 perimeter, base area times height. So that's 1/3 times 64 times 13.4. And when you put it into your calculator, you would get approximately 285.9 feet cube. So that was our first pyramid. Let's keep going. On this pyramid, the base again is a square. So it is a square pyramid. To find the perimeter again, it's 4 times S. So that would be 4 times 10, which is 40 feet. To find the area, it's side squared. So that's 10 squared, which is 100 feet squared. On this pyramid, we're given our 3D height, the red line, is 12 feet. We have to find the slant height. So again, you might want to isolate the right triangle formed by those two lines from the pyramid. Label our 3D height, which is 12. Label the bottom piece, which is half of 10, so 5. And this would, the hypotenuse of the right triangle would represent the slant height, which is the blue dashed line. So we can use Pythagorean's theorem again to find the slant height this time. And since we have A and B, we're going to add. So it's 12 squared plus 5 squared, and take the square root of that, and you would get 13 feet. So that's nice that it's no decimal. And now let's find the lateral area. Again, 1/2 perimeter times slant height. So 1/2 of 40 times 13. When you plug that into your calculator, you should get 260 feet squared. Total area, again, is 1/2 perimeter times slant height plus the one base. In other words, our lateral area plus our base. So 260 plus 100, which is 360 feet squared. The volume is 1/3 base area times height. So 1/3 times 100 times 12, and you'll get 400 feet squared cubed. So that's our second pyramid. On this pyramid, again, the base is a square. So it is a square pyramid. Find the perimeter. Again, it's 4S. So that's 4 times 18. Which is 72 feet. Base area is side squared. So 18 squared, which is 324 feet. Now on this picture, we don't have either heights. So what we're going to do is use this 15, which represents the edge of the pyramid, and draw a line that connects that 15 to the red 3D height. And that would form a right triangle. So this is our red 3D height. We don't know. The edge is 15. Now, to be honest, this is also a right triangle where this is 4 and this is 4. So it's an isosceles, right? I'm sorry, 9 and 9 because it's half of 18. And thus making it an isosceles special right triangle. So at the end of the day, that missing side would end up being 9 square root of 2 because it's the 45, 45, 90 right triangle. This one that I drew on the actual square itself. So that's how we find that bottom piece. Now that I have two sides of the right triangle I've isolated, I can now find my 3D height because I have A and C. So my 3D height would be 15 squared minus 9 square root of 2 squared. And when that's put into the calculator appropriately, you should get approximately 7.9 feet. And now I have my 3D height. I'm going to use my 3D height to form another right triangle like I've done before where I had the 3D height. So that again is 7.9. I have the part of the square, which is 9, and this would represent the slant height. So now I can find the slant height. Again, using Pythagorean's theorem. I have A and B this time, so I'm going to add. So that's 7.9 squared plus 9 squared, and that would be approximately 12 feet. I'm sorry, I forgot to put feet squared on my base area. And now we have all of our pieces. So we had to do Pythagorean's theorem twice. Anytime you're given an edge, only in none of the heights, that's just the nature of the beast, sorry, that you would have to do. And you would have to find it in that same order. Find your 3D height first, and then use your 3D height to find your slant height. All right, now I can find my lateral area. 1/2 perimeter times slant height. 1/2 72 times 12, and that's about 432 feet squared. My total area again is 1/2 perimeter times slant height plus the base area, which is your lateral plus your base. So 432 plus 324, which equals 756 feet squared. And then volume, 1/3 base area times height, 1/3 324 times 7.9, and that is approximately 853.2 feet cubed. So the pyramids are fun. And it's really not that bad. In just about every situation, you're going to have to do a little work. Sometimes you're given both height, the 3D height and the slant height. Sometimes you're only given one or the other. And then sometimes you're not given them at all. So now to cones. Cones is not that bad. So one example would be plenty for a cone. So the base shape of a cone is definitely a circle. You're given the diameter of our circle. So to find the radius, we're going to take our diameter and divide it by 2. So that's 40 divided by 2, which is 20 meters. To find our 3D height, it would be this red dashed line again. We're going to have to use Pythagorean's theorem. Again, this is 20. And we have A and we have C. So we're going to subtract. So the 3D height would be 29 squared minus 20 squared, which is approximately 21 meters. The slant height, thankfully, is provided for us. And it's 29 meters. Something that was left off, but I do believe it's equally important, is finding the base area. Since it's a circle, that means it's pi radius squared. So that's pi times 20 squared, which is 5,126.5 meters squared. So 5,026.5, in other words, meters squared. Now to find the lateral area of a cone, the formula is pi times radius times slant height. So that would equal pi times 20 times 29, which is approximately 1,822.1 meters squared. To find total area, it's pi times radius times slant height plus pi times radius squared. In other words, lateral plus base. So that's why we did the base in advance. Hint, hint, wink, wink. So that's 1822.1 plus 5,026.5, which is approximately 6,848.6 meters squared. Volume for a cone is the same as volume for a pyramid, 1/3 base times height. So that's 1/3 5,026.5 times height, which is 21. And that would give you approximately 35,185.5 meters cubed. Now I left off one example, but I'm confident you could finish it and take a picture when you're done. This concludes your notes for today.